Hello, and welcome to yet another coding session. This time I've got the assembly open here because we're going to continue working on Bangalang. Last time we introduced arrays, so if I go to the source code, we can see here we have an array and we're accessing elements of the array and passing them to procedures and stuff. But just to simplify things, I did make it so that you can't perform operations with whole arrays. So I couldn't do array2 equals array, can't do that sort of thing. I can't just pass an array into a procedure. So we kind of skipped that part, mainly because I sort of thought that means we need some sort of memory copying operation, and I thought maybe that's just something good to sort of cut out of the previous episode to just to make sure we don't go too far over time. And I was kind of investigating, how can we get that copy going, and I kind of got sidetracked a bit. We'll get there, but I kind of figured out that we need to lay a bit of groundwork to really get this copy working well. And what I also realized is, I would like to optimize our assembly, and I think we can sort of get two birds with one stone here. So let's work towards this, optimizing our assembly, and while we're at it, we can sort of lay the groundwork for some copying of arrays. When I say optimizing assembly, for example, here we have a declaration where we just move this into R8 and then we move R8 into the stack, and it's kind of like, why don't we just do this? Why don't we go direct? We would in this case need to add keyword, I think. I don't know, we'll figure it out, because if you just do this is just a memory address, so like how big is that? I don't think the assembler knows, so we need to use keyword to tell it. So that's one place where we could optimize. Assignment also, this could be just one operation, one line. That's the main place where I feel like we could improve things. We could also potentially make the binary operators better, because at the moment, we're just like, we're putting this number into here and then we're using it. So I feel like we could streamline a lot of this moving around of things from register to register for like no real reason. This is the kind of thing I want to optimize, and I think that's going to make our assembly a lot more concise. So let's have a go at that. We haven't spent much time in generation recently, but I think this is going to be all generation. Actually, I think I'll go back to the bottom. I kind of like starting from the bottom, I think. Well, I don't normally start from call. I kind of think of primary as the bottom. So one of the things that I think is going to help this, because we're returning. So this is kind of already showing part of the problem. We have a memory address. In this case, it's a stack address, and we're moving it into a register immediately, so that we can come up here. Because what is this? This primary. So that could end up, in one of these two. Could be that register. Then we move it to even another register. This is what I showed before. So I think let's start here. And instead of doing this operation, I want to go back to, I think it's actually what we originally had, which is kind of like just, it's more like this, just return the location that it's in. and use that in our operations. But I want to do it a bit differently this time. At the moment, we have a lot of location variables around the place, and these locations are just strings, and they generally refer to registers. I don't know if they ever refer to anything else. Usually they're the names of registers. But here I kind of want to expand on that because I think it's going to give us a bit more flexibility and return a struct. So like, for instance, this is a memory pointer to RSP plus some offset. So I want to make a struct that can give us all that information, because this here is not a memory address. This one is just an immediate. In assembly, they call it an immediate, but it's it's a number. It's a hard-coded value. And then the other thing it could be is the register. So I want a struct that can tell us, what is it? And I'm not really sure what to call it. Maybe we can call it memory. I don't know. Let's see. So if I go to the top and I make this memory struct. Whoops. So it's going to have a type. Type, just like basically all of my structs. So memory type is a enum. And what did we say the options were? There was register, like a pointer to memory, and an immediate. It's like a hard-coded value. So that's the type. It's going to have I'll give it something generic like value. So that could be the name of the what it's pointing to. So in our case, pointers at the moment are always going to be to the stack. So it'll always be RSP. Or for a register, it'll be the name of the register. Or for immediates, it would be the actual value. And then we said something else that we need to have in there, an offset. I'm not sure if it's necessary to have a number. Been doing too much TypeScript. Go away, notifications. I still haven't learned to turn them off. Maybe one day. So that's a piece of memory. If we go down here, we want to return the memory that we have put our primary into, or maybe not even the memory we've put it into, it's just the memory where it exists. So that would be, in this case, this is an identifier, so it's a variable, which means it's something on the stack. So it's a pointer to RSP with an offset of offset. So we don't need to do this, do we? We basically don't need to do that. And I kind of don't like how long this is. Can we break it up? Can we do like, this is it's like the variable position. There we go. So this is the offset. All right. So that's done that one. What do we need here? This is an immediate. The value will be node.value. And the offset's always going to be 0 for an immediate. You can't offset an immediate, so I don't think we need any of that. So actually we've got less code. That's kind of nice, actually. And here, well, this is a bit interesting because we've got generate primary, which now we're saying could just return an immediate or a pointer, which means we can't just put that here. Negate, I'm guessing, has to be on a register. So we kind of need a register. A register location. And that would be, I guess register needs to return a location now. One of our struct, a memory struct, I mean. So what register do we want? We want register num, and we need to tell it the size. So we go to the size here. That's all we need for a register, right? Yeah. So then actually what we need to do is first move it into that register from location. The thing is, this is a struct now, so we need to be able to print it. We need to make like a new utility function somewhere down here, I guess right at the bottom, for printing a location. So we're kind of turning it into an operand, I guess, for this. Let's call it operand, and it takes in a memory location and it returns a string. So how do we do this? I guess it depends. We need to like switch on location.type. We actually get to do a switch, which is not partial. We should be handling all the cases here. So in the case that it's an immediate, we just return the value, right? We don't need to do anything special. Sorry, location.value. So used to doing node.value. What's the next one? A pointer and a register. So the register also is just, oh, this is interesting. Well, actually, maybe we should do some error handling. But I mean, yeah, let's just put an error there. I'm thinking like, I feel like Odin should be able to handle this. It should be able to say, he's handled all the cases and he's returning in all of these, so we can't possibly come down here, unless this memory is corrupted and it doesn't have any of these. I guess that's possible. Anyway, unsupported memory type. So yeah, that should be what we need here. So whatever it is, it should end up in here. And then we move to our register, then we negate our register, and we return the register location. Okay. But it does not like that because we need to remove memory, return memory. And I think what we're going to do actually is return memory from these. So here we have a register, Registers can't have offsets, so that makes it quite simple. Go away. I can see the cat hanging around. I've just realized I haven't fed him, so I'm just going to pause for a second. Oh, I can't do it here. Okay, we're back. Poor cat. I was supposed to feed him a while ago, and I've totally forgot. Now, where were we? That's right, we were switching these to be memory structs, which is a very simple conversion for registers. Okay. Now that means that up here where we were using a register, we also need to convert that to an operand, like so. Very nice. And these here need to also return memories. So let's go down to this call and have a go at this. I'm surprised that's not. Oh, I guess this is a register. Yeah, these are registers. So yeah, let's have a look through here and see if there's something else we need to change. So we have this location. We need to operand that. And then we need to operand these. This is one that I've noticed from before. So this is moving from register 8 to some other register. So this is an optimization I think we can make, because what if this number is also 8? Then this is a pointless operation. So let's say if register num does not equal 8, then we do this. Otherwise, there's nothing to do, right? Because generate expression has not been updated yet, but that'll get resolved when it does. Cool. I think that's it for that one. I guess we need to create that location regardless. And this is where it's going to go to as the result. That's kind of our calling convention, right? Oh, that's, now that I think about it, what do we, well, it's because yeah, I guess in this case we have nominated that register, so kind of the thinking here is that you need to return it in the register that we nominate. Okay, let's leave it for now. We go up to here, this needs to return memory, and so does, in generate there's only one generate expression. I was thinking of, like type checking where we have generate expression 1 and generate expression. So this is still good. Happy with that. So we have all these locations, great. But now down here, we don't want to just have locations. This time, let's go LHS operand like that, and we do an RHS and just result. So maybe I'll call that result as well, result location. What are you complaining about? Oh, because you should be operand. Okay, so now LHS location becomes LHS operand. RHS location becomes RHS operand. And location becomes result operand. And what is this? What is this? This should be result location. We can't move to a register number. I think this needs to be result operand also. Oh, and so now these are registers. They need to be converted to operand. Otherwise, we're just going to have a whole bunch of a mess in our assembly. Come on, you're all right, aren't you? Aren't you all right? Oh, do you need another one? There we go. So I think that's all right. We just convert them to operands, put them in here. Q. Up here also I noticed that they need to be converted. Whoa. Did not want to jump. Cool, and we're moving this location here. This can be, this is also an operand location. QQQ, I think that's it. Assignment, that's an operand. What is this? Offset. Is this the same as we had? That's the same as we had down here. So let's just take that. It was the same, wasn't it? It's using LHS node, but it's stack size minus the variable offset plus the data index plus the data size. Yeah, so it's just a matter of using the correct node. Let me generate that expression. So, I mean, we put the offset in there. I mean, okay. We could, you know, we could create a location and put it in there. Let's see how we go. I think this is fine for now. This location is operand location. Looks good, I think. Clear scope stack, that should be fine. Yeah, I'm not really expecting much in... Okay. Yeah, the tests. Same here. And there's more tests up here, right? Here's a test. The LSIF location and with the location. Copy that, probably have to use it again. Or maybe not, maybe there's nothing more up here. Procedure. No, I don't think we need anything in here. All right. All right. All right. So then, does that build? Apparently. Yeah, and here we go. This is looking more like it. You know what? Let's stash and do a build. How many lines of assembly do we have? 327. Pop that out again. Do another build. 257. 327 to 257. So that's 70 lines of assembly that we have removed from our basic little program. So this makes a whole lot more sense to me, you know? It's like we allocate space and then we assign the value. Or here we just assign the value. Cool. And with our arithmetic, do we have a bit more? Yeah, see, look, you know, we just like, we allocate some space on the stack because it's a declaration. We do have to move it one thing. Yeah, we do have to move at least one thing into a register. Then we add it to the other one. And then move to register R10, R10. That seems a bit pointless, doesn't it? Move to register. That seems a bit pointless. Yeah, well, I guess especially pointless in this case because it's that is a negate, isn't it? Yeah, that's for a negate. That does seem especially pointless because it's the same register. But what I just realized is this generate primary could already return a register, in which case there's no need to do that at all. I think what I might do is make another little utility. Let's put it like up here even. Move to register. All right. And we pass in what we want to move and the register number. Maybe we'll default that to 8. Because in some cases we probably don't care. No, let's just go like that. So then it's like, okay, if location.type is register, there's nothing to do. So let's just return the location. So that needs to be able to return a location or a memory. Otherwise, we want to set up the register for the number. We also need to specify the size. So then should we just pass in a register? No, that's fine. We'll just leave it as it is. That's good. That's fine. It's fine. We do need the file though, because we are printing some assembly. So move to register, register location, location. Yeah, I think that's it. So we just extracted that to its own procedure, which will replace this location. Oh, no, yeah, we still need the negate. Yeah, so we get the primary, and whatever location it is, we move it to a register, which might do nothing, and we get the result of that. We negate that now that we know it's in a register, and then we return. We need to give the size, so that'll be this guy here. Right? Oh, and the file. There we go. Okay, so let's have another look at our assembly. Yes, we have add, multiply, multiply, negate. Add. I mean, we could just add R10, right? Again, here we could just, if we know it's in R12, why are we moving it to another register? I have a feeling that's going to be like a little bit more complicated to resolve, so maybe we'll leave that for now. We've already optimized these a fair bit, and then at the end we assign to the stack. Yeah, of course, because it's a declaration. Assignment looking good. Test. Okay. We never did. We made that utility function, but we never implemented it properly. This pointer here needs to be something a little more involved. It's like we need to concatenate a few things. So it needs to be in square brackets, for one. Like that. Whoops, that still works. So that's better. And probably in this case is actually correct. But if we have an offset, if location.offset is greater than 0, then we also need to include that offset. So we need to have like plus the offset, which is a number, so we need to convert it with strconv.i to a. Which means we need a buffer. I'll just allocate 8 bytes. That should be more than enough. We need a slice of that buffer. Cool. All right. I'm immediately noticing this +0 here, which feels inconsistent now, because this, yeah, and that's because here, this is where I think before we said, you know, we were just going to leave it. Like if I go to assignment, where's assignment? I think it's below. If I go to assignment, yeah, see, we just have like this in here. So probably would be better to have operand used there. We'll get to that. We'll get to that. And okay, so what else we got here? Here's an if. So we do a subtraction and test the result. Looking good. Okay. I don't want to like look through the whole thing. That's going to take forever. Searching for issues. But we just need to keep an eye out, I think, from now on, like if there is any problems. Let's see what happens if I try to execute that. So we have a lot of errors. Let's go to the top. Line 5. there is a problem. Operation size not specified. This is where I think it needs to be like this, keyword, quad word being 8 bytes, or whatever size makes sense. So let's make another utility function, utility procedure. Got move to register. So now what do we want? We have like operand down here. It's like operation size. And I guess it's just like a conversion from a byte size, or just, I'll just say size, I don't know, size. And it's a switch on size. So case 1, 2, 4, 8. These are the supported sizes. Let's say unsupported operation size. Let's just say unsupported operand, maybe, because that gives us a better hint as to where the problem is. So if it's a byte, I'm pretty sure that the names of these are, we need to return a string in the right direction. Byte, word, D word for double word, and Q word for quad word. Don't ask me why, but a word is 2 bytes. Now, where do we use this operation size? That's a good question. That is a good question. So, well, where have we got the problem? That's a good way to find out. So it's a move, kind of anywhere where we have a move. Yeah, this is memory to memory, so it's probably also the case. Any of these moves, we don't, yeah, whenever we do a move, we don't know. So we'd have to like go %s and then operation size and put the size in like that. But this is where actually, this is sort of getting to, like I was talking about copying a little bit at the start. I think we want to extract this also, making a lot of utility functions today. So it's kind of like, well, I don't think we need to return anything. But if it's kind of like we're going from source to, do we need a size? Let's see. Source to destination. Oh yeah, we do need a size. We just said we needed a size for the operation size. So that's going to take this. So this is the operand size from the size we're given. Source to dest, like so. Okay. And we kind of need to implement this for like all the different combinations of locations, right? Like if the first thing I want to say is if offset, if the destination.type is immediate, well, that's an error. Bug. because that doesn't make sense, right? This is a hard-coded value. You can't move to a hard-coded value. And the other case I thought of was if we have a register involved. Registers are of a known size. So maybe we can just, for that case, we don't need to put the size. Let's just call this copy. But if we don't have a register, then we do need to put the size, because we don't, in that case, we don't have anything that determines what size we're talking about. Oh, and just down below. Maybe I should move this kind of below here. I've just realized that this is our first customer. So we're moving from location to register location, and this is our size. Right, good. Okay, here's another copy. This time, this is our size. We use that so many times now. Let's go. Size, and then just put that in here and here and here, and we're going from location to location. Cool, I like that. It's nice and concise. Here's a move. From location to the top of the stack. So I think for the top of the stack, we could just say, pointer to RSP offset 0. And the size is, call it data size. Okay, so we copy to the top of the stack. Nice, nice. No copies there. There are quite a few here. So in this case, we are copying from LHS to to result. LHS location to result location. And it's the same for all of these. So then this is kind of like, I don't think we need to say do it. It's just like, that's it. And later we could look at potentially even optimizing this out. Does add need to be on a register? I think it does. But again, we could just have like a move to register here. Yeah, why not? I don't see the issue with that. What does move to register expect? It expects the location, the number, which is register num, and the size. Is it the size? Yeah. Okay. So I guess that's the result location. And then operand of that. So we do the same for these ones. I hope this works. Like that. the RHS operand is always the same. Yeah, don't need to do anything special there. Division is the crazy one. Yeah, for division, we need to move it into specific things anyway, so I don't think there's going to be any optimization there. So that's all right. Cool. All right. Do we want to do it here? I guess, yeah, why not? So this is file, and we're going into register AX. We're going to have immediate 60. Like so, right? Yeah. And this is going into DI, and the thing that's going in is location. We are losing a bit of nice messaging here. Maybe we can have like an optional comment. It doesn't mean we have to do a string concatenate. Let's just take it off. Maybe let's leave this one for now, just because I kind of like the comments there, and it's not a big deal to leave it as it is. This one we were definitely talking about moving, changing. So here we're going from location to an RSP offset. And here's the data size, like so. Here we're going to the top of the stack from the location. We already have the data size. Did we? We didn't have it here, did we? No. Yeah, so that's that one. Any more? I don't think so. I think that might be it. We've got these tests, and yeah, I think that's it. So let's compile that assembly. See, now we have our keywords. Very nice. All of our top of the stacks don't have a +0 anymore. That's kind of nice. Let's see. Let's try this out. Still a bunch of invalid combination of opcode and operands. I think it's quite a lot less errors than we had before, but still errors. So this doesn't work. Can we do it like this? Still an error at number 8. Oh, because I got rid of it. No, just because it's no good. So memory to memory, maybe move can't handle memory to memory. But the nice thing is, because we have because we've replaced all of these things with copy, we can put another case in here. So here we're saying the source is immediate. So we know none of them are registers. We know we're not going to an immediate. So what's left is immediate to memory address to pointer, or pointer to pointer. Yeah, it can't be pointer going to anything else because it can't be going to a register and it can't be going to immediate. So we can do that. So this is still correct. If we're coming from an immediate to a pointer, that's good. But if we're going pointer to pointer, I did some digging and I found this here. Well, Grok found it for me. And this little bit of assembly here is saying that you can go from a source address to a destination address, and you can say how many bytes you want to copy, and then you do this repeat move SB. So every time you do move SB, it will copy from here to here, and it will decrement this. And when you do repeat, it means that it'll keep doing that until this gets decremented to 0. Oh, and these get incremented, so it's moving them forward and copying, the next byte, next byte, next byte. B stands for byte. Yeah, move S. I don't know what the S is. Oh, I think it's move string. I mean, I don't know what it's got to do with strings, but move string byte. So this is kind of like our general purpose copy. These are like special copies that are nice and quick to do, but if we can't do those, then let's do these. This one does not need an F line. Instead, yeah. That'll be a do it. I guess we'll do like this copy prefix. Okay. Let's do that. So that's the source, the dest, right? It was in that order, source, dest, yeah. And count. And then we just need to substitute in the correct things. Which is source is operand source, destination will be operand destination, and size, I'm pretty sure we brought in, that's the size in bytes, yeah. So, and the one other thing, and I asked Grok about this too, I asked Grok, what happens if we have something like RSP plus 10? Because up here, it's just saying, source, dest, which are simple addresses without offsets. And it said you can use here. So instead of this, you use this. This is load effective address. So it finds this address and puts it into RDI. So we need load effective address for these two. All right. Maybe that will work. Okay. Because I did not actually substitute them. That's an integer. Boom. That looks nice. I mean, it's like 4 lines, which kind of sucks. It used to be 1 line. But let's see how happy NASM is with it. Okay. Yep, so now we're down to like, what is it, 7 errors. Let's go to line 40 and see what the problem is. Probably we need to put these in registers. Maybe test only works on registers. So that's like our ifs and fors, isn't it? Scope for if. Yeah, here's the test. So we need to do location equals move to register. File location. What else did we need to give it? The number and the size. In this case, we don't really care what number it is. What is the size? I guess the size we know is 8. Because we have said that for if statements, the expression is a 64-bit integer. I think we can, though, do expression node dot data type dot name. I think we can do that. That's probably better. Actually get the size. So we've moved to register there. Move that one to a register, right? Needs to be before. Well, it doesn't need to be before that, does it? But I don't think. Yeah, I think that's okay. Oh, wait a minute, because it's not, yeah. Because we need to do this node. Yeah, so we can't do it after the increment because this would be wrong. Okay. And then we have a couple of tests down here. We should really refactor this procedure because I think we're just duplicating this stuff. So this one is expression node and location. Like so. Like so. Not like so.
I'm not quite sure how to help you with that.
Oh, Jesus. Alexa, I didn't want your help. Man, that scared the shit out of me. Okay. So now when we have our if, yeah, so we're doing copy now. Copying it into a register and then doing the expression. Whoa, no errors. But is it actually going to work? That's what I'm more worried about. Links runs, didn't crash or anything. We get 0 back. Not ideal, because yeah, this is still our. So we took the number 4 and we shuffled it around, and then we raised it to the power of 3, and I believe the answer is 64. So let's have a look at that chunk of the code. Should be, I think it's after the for loops. Yeah. Let's go. So there's the for loops, for one end. So we allocate 32 bytes because it's 4 bytes times 8 is 32. Then RSP plus 20, which is 4 5s, 20. So that's index 5. We assign 4 to it. Sounds good. Then we do a memory copy from there to index 3 4s are 12, so into index 3. Great, so it's in plus 12. And now we do the return statement, this one here, which is going to call POW. So we allocate space on the stack. We do a memory copy of 4 bytes to the top of the stack from where we just put our 4. Okay. That's doing the actual copy. And then we take, we allocate 8 bytes. So I guess it's this is a 64-bit integer. So there's an I64 for power32. And then we copy the number 3 into it. Yeah. We call power32. We clear the stack. You know, we put this 4 and this 8 on it, so now we take them off again. And we exit with R8D. Okay. I'm immediately, well, I guess it happens in here, but like, we haven't done anything with R8D. So I think it's the calling convention. That's right. It's the calling convention is that power32 should put it in R8D. So let's go to power32. We're allocating a 32-bit integer. We're doing a copy to the top of the stack from plus 20. So I guess that must be our, this guy here, the 4. Yeah, I think because we copy it, right? Yeah, we're copying it into a new variable called result. That's what that is. Then we assign, which is taking RSP plus 12. It's going into a 64-bit register, so that must be, yeah, this is here. So it's taking this and decrementing it. Yeah, we subtract 1 and then we put it back into the memory address. Yeah, so I feel like this could go here. Maybe could be an interesting thing to try. Then this would be reduced to 1 line. Quite a lot of our stuff would actually be reduced to 1 line. But yeah, this is our decrement, and then we go into the for loop. So we copy what we just decremented into R8, test it. Here's our R8D. Okay. We assign to R8D the top of the stack gets assigned to R8D, then we multiply it by what we sent in, yep. And then we put that on the top of the stack. Cool. Then we assign R8, subtract it. Oh yeah, we're doing this again. Yeah. And then we return so I feel like R8D should have the right result in it. What I'm looking for was where we call it. Yeah, we exit with R8D. And power32, I think, puts the... Well, I mean, technically it's moving it into RSP, right? It's just kind of lucky that we were using R8D as an interim. Like, because we were talking about making it so that it would just be this, right? That we were saying it would be nice if it was just this, in which case it's not touching R8D at all. And R8D is our return. We don't have anything. Here's our return. It just says jump to the end. So our return, because previously, let's go to our return generation. let's go to our return generation. I think it's here. Yeah. Yeah, because we generate an expression. So previously we knew that would put it into register 8. In this case, R8D. But that's not always the case now. This location could have just been a pointer. I don't think it could be I guess it could potentially even be an immediate, actually. You could just return a constant, right? So I think we need to do like a move to register. File location, register 8. And we have a data size. Oh, data size is there. So we need to move it into a register. Yeah, so now we're copying it into R8D and returning. So did that solve it? No. Okay. What's the issue here? What's the issue? PAL32. So we do all this math. RSP plus 20. I feel like those are the correct indexes because the instruction pointer is 8 and we've allocated 4. So plus 12 should be the second parameter. And that parameter is 8 bytes. So plus 20 should be the first parameter. So I think all those numbers look right. And the top of the stack, which we create that variable here, that top of the stack is what this here is like our actual running multiplication, you know, and PAL32, that's this here. So I think that's all good. Then we move it into R8D. So let's go back up to the call site. Here's the call site. Afterwards, we clear the stack and we do our exit. I really don't know why that would have 0 in it. It doesn't make any sense to me. This is where I wish, you know, I had some sort of way of, I need to investigate this. I need to be able to say, like, at this point in the code, I want to like just dump, maybe just dump, like what is in the different registers, what's the different memory addresses, you know, what's on the stack, for like debugging, because debugging can be a real pain. Yeah, I'm sure the result of PAL32 yeah, so we don't clean that up until after this, so that's good. That was another worry of mine. And when we generate our return, Yeah, we're moving it to register 8. It all makes sense to me that it would work. Return. Is there any issues with my copies? Let's try, okay, let's try doing just a simple, something simpler. Let's try that. So now we just have this return, we're just returning, yeah, RSP plus 12. Okay. Let's see if that works. Need some way of narrowing things down. So that returns a 4. So that's good. If we take the code from PAL32 and we throw that here, and we were saying, so this is the original. So we were saying that X was a I64 for 3. I think there's already a result, so we'll just go result 2. Is array 3. So we're doing it without the procedure call. Oh. Index out of bounds. Index required for result 2. That's type checking, right? Failed to type check primary. Failed to type check primary. Oh, it should be variable. Failed to type check variable. Index required. So index required means that the length is greater than 1 and we haven't indexed. But the length is not greater than 1. It's just taking one element from this and putting it here. But we're taking just the data type from the variable, and the variable does have a length of, what is it, 8 or something. So maybe we should not be doing that. A data type is it's a name, right? Yeah, name and a length. No, just name. Need to declare that. So then we're actually saying the length of that is greater than 1. And we're not indexing right now. Then that's a problem. And we set that to that. And this length here is also that length. Okay. Undeclared identifier num at line 82. That's true. Because actually, I think it should be that, like that. Yeah. Okay, what do we get from that? 64. I wonder if this could have been the issue. So this would have had the wrong length. And that length is used in generation to determine the data size. Ah, yeah, so that would have been a problem. I didn't spot it anywhere in the assembly. But I do feel like that could be a problem. So that's parsing, yeah, that's fine. So that's where it is in generation. When we do a declaration, it needs to know. Yeah, it's just a declaration. Oh, is that the only place? Interesting. Okay, so then let's take out this test code and run that again. Did I fix it? About 50% confidence here. Yeah. Still an issue. Well, this is turning out to be a real pain, isn't it? I mean, I'm super happy with where we've got to with our... I guess we could also... No, but I think all the copying and stuff must be working because we did it just without a procedure call. It's around the procedure call. So there's the generation of the procedure itself. Let's have a look at that. Stack size plus equals, yeah, we don't need to times that by length because we know it's never going to have a length. Generate scope. Okay. What about the call site? I don't think there's anything we need to change where we've just looked. So let's try the call. Is there anything we're missing here? Also, parameters cannot be arrays, so we don't need to worry about the length. So we're generating an expression. Using the file, the param node, the context, getting the data size. Updating the stack size. When we generate an expression, do we use the stack size or something? So this here is where we have the call, right? This is the call. Do we have any of these offsets wrong? Ah, look. Look. We refer to RSP plus 12. That's where we copy into. That's our destination. Then we subtract from the stack, and then we refer to that same number. So that is, and in case I wasn't being clear enough, that should now be 16 because we've moved the stack pointer since we referred to it here. So that should be a different number. So if we go back to our call, I don't know why we're not on the call now. Here we go. So where would this copy happen? is it in the expression? We allocate some space. Yeah, we allocate some space. Here's the allocating the space. Here's the copy. And that location, there we go. The location we're copying from the source doesn't have this updated stack size. Yeah, so I thought I should have thought to come here earlier. So does it just need to be like that? We allocate space. These are the two steps, right? We allocate space and then we do the copy with the expression into that space. Now it's 16. Okay. Okay. Something else I'm kind of noticing here is that we add to the stack size before the call. Here's the call, but then we clear it out, but we don't subtract. And somehow that's not a problem. I think we need to do that. Subtract it all. Okay, let's try this. 64, yes. Okay, we're going a bit over time. Sorry guys, that bug was a real pain in the ass at the end there. Got me sweating. But this is kind of where I wanted to get to. I'm pretty happy with this. What did we say? It was 327 when we started. Now it's 284. So we've got much more efficient in terms of numbers of instructions. We've got much more efficient. Even though this one is like 4 now, we still went down a fair bit. And having this here, I think is great because this is going to be, I feel like, quite trivial now to copy arrays because we just need to copy a bigger chunk of memory from address to address. I think that's not going to be difficult. Great. So I'm quite happy with that. I feel like our generation is a little more mature, you know. And now it's time for me to go have some Indian food. So thanks for stopping by for so long. I guess if you're listening to me now, you stuck through me fumbling over that bug for a while. We didn't even change this file because we didn't add any new features. But this is much nicer assembly. So yeah, ciao for now.